Okay, to begin with, let's go over the very, very basics. 2, 1, 3. Can you tell by me writing that whether it's a point or a vector? No, you can't. But if I put it in this context, x, y, z, you still can't tell. But if I do this, wait, I actually want to use, I made a special one for you. Hold on a second. Yeah, okay, sorry about that. I'm going to have you change this to 1, 2, 3. And now you can tell that's a point, can't you? Because there's the vector, which is the part at the end, which is after the t. And that is going to be 2, 3, negative 4. Double check that you copied that exactly right, because obviously if one of those numbers is off, you won't be able to solve it. So now I would suggest you change colors. I'm going to use red for another vector, x, y, z. And that one is going to be 4, 8, negative 12 plus lambda. We wouldn't want to use the same t because it's a different vector equation. And this I kept simple, 1, 1, 1. Okay, those two vectors will either just intersect or they will intersect at the same time and be in the same spot at the same time, in which case they collide. Now you're going to need equations for this, but let me just show you how you could do it all at once. I know some of you guys are into saving time like I am. Do you get all of this? All of these are x equations. So I could just go directly to this. 1 plus 2t equals, from the bottom, 4 plus 1 lambda, which is just lambda. See how I got that to be one of my master equations right off the bat? It saves you from having to write 6 separate equations. Just go right to that. And then do the same thing for the y equations. And then do the same thing for the z equations. Now this one, you're going to have to use either substitution or elimination to solve your system. It's good to have one last chance to practice this. I think it's probably the toughest thing on the test. And I'll pause for a minute while you give that a shot. Okay, I'm going to just continue for a little bit to see if you can catch any mistakes early. Now, one of the more powerful ways of solving systems of equations that a lot of kids forget is called elimination. And I'm going to go through and multiply everything by negative 1. You might not understand why until you see what I do with it. If I now add straight down, you can do that because effectively I'm just adding something to both sides of the equation, but the left side and the right side are equal, so I can do this. So I take 1 lambda plus negative 1 lambda, and the lambdas cancel. That makes it so I've only got one variable, which is really nice. And 4 and the minus 8 make negative 4. And the 2t and the negative 3t make negative t. And the 1 and the negative 2 make negative 1. I know that's not the way a lot of you would have solved it. A lot of you would have used substitution, which is totally fine. But I'm doing something called elimination. I know you were taught this in higher algebra, and in my opinion, when it works, so much easier. Now, substitution would have gone like this. You would have solved for t or for lambda. Lambda would be a little easier, actually. So maybe I should just show you if I would have solved for lambda, I would have subtracted 4 from both sides, and I'd have negative 3 plus 2t. And I'd go put that into the other equation where the lambda was. That would have also worked. But boy, mine got me to a nice simple equation really fast, so that's always good. And now I have negative t equals negative 3, so t equals 3. And my suspicion is that since you guys have gotten good at this, I probably would do the most complicated kind, which is a collision at t equals 3. So then my guess is that the other variable is also 3, but I don't know that for sure until I check t equals 3. I'm going to go stick that into one of the equations. Doesn't matter which one. So if I choose to put it in this one, once I know t is 3, then this would become 1 plus 2 times 3 is 6, which makes 7 equals 4 plus lambda. And look at that, lambda is probably 3. Yup, lambda is 3. And so if lambda is 3 and t is 3, then that means that's the special time. At 3, they're both at the same spot. That means it's a collision. And where is the collision? Well, if I put in t is 3 or lambda is 3, either one, they better both come out to the same point. And if you double check it, they do. 1 plus 3 times 2 is 6 is 7. This key spot is at 7. Comma, or not really comma, but 7, 11, and I think it's 12 minus 12 is negative 9. There's your key spot, 7, 11, negative 9. And then if I should just double check it, I'll go down and do the bottom one. 4 plus 3 times 1 is 7. That's working out. 8 plus 3 times 1, 11, and negative 12 plus 3 times 1, negative 9. Look at that. They're both at the same spot at the same time. They collided. Any questions about how to do that? All right, that's complicated algebra. But if you're like, oh, that's just too complicated for me, I'm giving up on that, then I really would caution you about, if you're not willing to even like work through a problem like that, calculus is going to kick your butt because it's got a lot of algebra in it. If you're willing to step up, hey, you make a mistake, no problem. I'll try again. If that's like, you're not scared of this, then AP Calc is your way to go. So just trying to caution you that you don't want to take that class without strong algebra, or at least the willingness to buff up and improve your algebra. All right, now here's a couple other concepts. What if I asked you the speed of this? Don't say it, figure it out. Figure out the speed of that. Graham, it's the same exact thing as if I asked you what?
What's the magnitude?
What's the magnitude? And what is the magnitude?
Square root of 21.
Square root of 21. Square root of 2 squared, 1 squared, and 4 squared. All right. Now what if I asked you for the unit vector? What do? Remember?
Put 1 over.
1 over. Boom. That right there is the unit vector. And what if I asked you to make it have a length of 8 now? You slap in an 8 here. Or really what you're doing is multiplying it all by 8, but the 8 would climb up on the top because 8 over 1 makes the 8 go up on top. Okay, good. What else could we do? What if I said I want it to go in the opposite direction? Don't overthink this. Cooper, you know what to do?
Negative.
Yeah, make them all negative. Negative, negative, and oh, that last one was negative, so it changes to positive. Now it's going in the opposite direction. That's all there is to it. What if I just gave you 2 points? 2, 1, 4, and you wouldn't be able to tell that wasn't a vector, so I'm going to write point above it. And let's say I have another point, 1, 1, negative 2. Would you please tell me the vector that goes between these 2 points? I'll pause for a second while you try that. So one last thought, this is kind of like a slope, so that can tell you your vector, and this tells you how far up. Remember, it's rise over run, right? And this can tell you how far over it goes, so that informs you about how to do a vector. There's a problem like that on your quiz, and you'll see that when you look at the key for this quiz I'm giving in class today. The quiz in class is the same as what was by accident assigned in the worksheet called vector practice. And that's all I have for the video for today.